Today we're going to make slime. Remember, the goal of these videos is to make science with a purpose, and that purpose is innovation. In all of our videos, we're going to be learning vocabulary. So let's start with the vocabulary that is needed for slime. The first word is polymer. Polymer. So what is a polymer? All of these Lego figures are made out of plastic. In reality, technical term is polymer. They're made out 100% of polymer. Plastic is a behavior. So when something behaves plastic, it means that it can sustain elongation. It can sustain some deformation. Plastic is an adjective. It describes the behavior. Polymer is the noun. Polymer comes from Latin. Poly means many and mer means parts. Many parts. In reality, we can say many molecules. For example, have you heard the word polyethylene? Polyethylene is what many of the plastic bags at the grocery stores are made out of. Ethylene. This is the molecule for ethylene. So we have 2 carbon atoms, and each carbon atom has one hydrogen here, below, on top, below. If we have many of these linked together, we're talking about many. So there are thousands of carbon atoms linked together. These Lego figures are not made out of just one long molecule. They're made out of many molecules. And these have different sizes. So just imagine like spaghetti. Each spaghetti slide past each other. So when they're molten, the spaghetti moves, the molecules move, and they can reshape in whatever form you give it to the mold. When they're cool, then now they cannot move. Now we understand the basic structure for polymer. So it can be polyethylene, it can be polystyrene, it can be polypropylene. Polymers can be divided in thermoplastics and thermosets. Thermoplastic is just the example that I told you about spaghetti. The molecules can move past each other when the polymer is being heated, but once you cool it down, the molecules stop moving. So they move, you can reshape it into whatever form you have in the mold. So you can make hats and faces and legs and bodies, or other parts of Lego, and you cool it down and they stay like that. Thermosets, on the other hand, are basically thermoplastics that you add another chemical and then you cross-link the chains. So that means you have the molecules and you attach them to one another by some chemicals. So now if I want to move this chain, I cannot. This one is restricting the movement. Thermosets cannot be reshaped. So once you shape them, that's it. Tires, for example, it's rubber that has been cross-linked with sulfur. You cannot reshape it, but you can cut it into pieces and use it as a filler for playgrounds or other applications. The other word is cross-linking. Cross-linking is needed to develop the thermosets. We have to bond those molecules together. Now we have the 4 words that we need to start our experiment. Polymer, many parts. Polymers can be divided in thermoplastics and thermosets. Thermoplastics are the polymers that can be reshaped many times, and thermosets are the ones that have been cross-linked, so we cannot reshape them. They have been chemically bonded. The molecules have been chemically bonded to each other. Let's start the experiment now. The first ingredient is the polyvinyl alcohol. Polyvinyl alcohol means many molecules of vinyl alcohol. In polyvinyl alcohol, it might sound scary, but it is Elmer's glue. Second ingredient that is going to help to cross-link the molecules of polyvinyl alcohol is sodium tetraborate. Sodium tetraborate is better known as borax. As you can see, the polyvinyl alcohol is a linear polymer. You can see it flows. So the chains are actually sliding past each other. Just imagine spaghetti. You get spaghetti, and each spaghetti is one molecule of polyvinyl alcohol, and they slide past each other. Before we actually add the borax, who's going to cross-link the molecules, we can add color or we can add glow-in-the-dark. The glow-in-the-dark material is zinc sulfide. You can buy it online at Educational Innovations. It's tshirtsource.com. After adding the glow-in-the-dark, we mix it well. It has to be really, 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 really well mixed. Then we're going to add a hydrated sodium tetraborate solution. It sounds scary, hydrated sodium tetraborate. In reality, it's borax with water. So this is our hydrated sodium tetraborate solution. So you can see how it flows. This is what we get. It's nice, right? So you can play with it, you can shape it. But if you want to go back and make it flow, like the thermoplastic, you cannot. Now you have a thermoset. And this is the one with color. We did one blue and one glow in the dark. Okay, we turn off the lights. Look at our glow in the dark sample versus the blue slime. That was cool, right? Let's now summarize what we have learned. Oops. What is that we learned? We learned that polyvinyl alcohol is a thermoplastic, and when we added the borax, the sodium tetraborate solution, we developed the slime. So we cross-linked the molecules of PVA and we developed a thermoset. The slime is a thermoset material. This is great. So now you have some scientific knowledge. Now think about solutions that you can invent with this knowledge. What can you do with polymers? What new polymers can you invent? So I'm waiting to hear from you.